So you'll need your books for the color code resistors. You'll need your books for the formula for resistivity. I don't remember the page for resistivity, but it's this. Resistance is equal to resistivity, which is that of copper wire, length of wire times the area. This is resistance. This is the length. And that's the area. I can go over those if you want.
Been a long day.
Yeah. It happens.
I just took a class learning how to do a job we've been doing for 2 months. Just for, I guess, just for corporate purposes.
moved my class down here. Instead of down the other way.
You don't have to have an HDMI cable. I know it's over there. I was doing a C programming course today, and the instructor's computer will not accept code blocks for some reason. Just, I don't know, my vendor has now done it half a dozen times.
And it won't take
It won't take it. So what I was gonna do is gonna hook up the overhead to my laptop. But I gotta get an HDMI cable.
your laptop doesn't have VGA.
No. No.
That you know.
It just has, it's here.
Yeah, 'cause I think this is the only one that has a VGA.
Oh, really?
Oh. Mitch has a class the same time. Yeah, see, I can tell you, oh, yeah, this, they're really posing it.
So that one over there doesn't
I
have
don't think it does. Oh, shit, already shut it.
Did you lock it?
Yeah.
Next time you wait,
I'll take a look.
I'm in Thursdays.
I'll be in there tomorrow.
I'll
I'll be in there tomorrow.
Okay.
I'll take a look.
Okay.
And then I've got class Thursdays here at my house.
Okay.
That's the class going.
Okay.
It's a fun call. I will try and get to the regular stuff if you can. Are you gonna try and do that?
Yeah, I think so.
Yeah, that's a lot of my kids enjoy that so much.
See, I had the intro class last semester. Okay, I should have more of that because they were coming in after.
See, I did. Well, 2 years ago I tried. And we had so many snow days that I ended up with one, two class times for a week on that. So last year, I got through all 10 weeks. And then I spent 4 weeks on it. You know what? And it was just awesome.
Did you, how far did you get in my book? Did you get one?
When you logged into the course, all that stuff, it was pretty limited course.
Yours never does.
Yeah.
Well, and I have all that. As a matter of fact,
I didn't read the book.
no. But, but that's your stuff.
Mhm.
Okay.
And actually, I got it from Mitch originally, and then I modified it a little since then.
Yeah, I printed all of it. So I have all of it.
Yeah, and then I sold this.
You made it through pointers, I think.
Right,
And
all the way
then
back to the
that-
arrays and that.
Arrays, which is chapter 5.
No,
Chapter-
chapter 10, chapter 11. See, it bounces around.
I have my book in the car. I don't remember where.
Look, if I find where notes, I should have chapters.
Yeah, functions, chapter 5. Arrays is 7.
Yeah, so 7, chapter 9, strings.
Chapter 8 is pointers. And then it goes strings. So I was going to.
And then I can organize it from there, and then I switch over to Arduino, because that's all Mitch had covered at the end. Because I got the course, Mitch didn't teach it, so I got, yeah, I went through the book to where he did. That's when I got to Chris, I got everything Mitch has done. Because that's the degree what he does. And I was teaching that, and I got, you know, so I put that in there. Because it's, Mitch will work with you, it's not exactly speaking.
Yeah, it is. It is.
In that way.
And it's fun. Yeah, I'm gonna,
Every chapter, it includes,
yeah, every chapter's note is a problem, yeah,
Well,
and they
but
build on
it
it.
builds on the last, that's like a continuing that you apply previously as extra help for the student to do that. Or you did struggle.
Yeah, yeah. Well,
That's what I found over the years. Because I've done like the last 3 years, I've done 3 years, 4, 3.
So you actually had a half a dozen or so, boards.
Yeah, I gave all back to Mike.
Okay. Because he's hot on the Raspberry Pi now.
Yeah, he can vote for that. But he mentioned the teacher you're doing this. Which, yeah, he even told me, which I just telephone, I had him, I'll dig through my stuff, I'll dig it out for you. They should have all gone. He used their, I brought in extra meetings. Sisters and stuff, I sisters and stuff, I got that like about you. And then my boys, I had some about 7 second displays. Just 7 second displays. We got lights, kids, maybe 7 second chase lights. We used the loops and the calendars and all that stuff. The way it's been, so.
Okay.
I just order some. They all should have their own visuals to use.
They do.
So I'm giving them up to 5 whole hours.
Yeah. Okay. Sounds
So
good.
I do it for you.
Yep, sounds good. It is, I like it.
Well,
I like the name guys were, it was 420.
What chapter is it?
I'm just finishing up the 3rd chapter, I'm going to start chapter 4.
Which was, I never remember the chapters.
I remember, chapter 3, wildly,
Oh, okay, yeah.
answering the prompts,
Right.
scanning.
Okay.
And then Thursday, print up and scan interactive data. And then more programs, yeah, more programs. And then I'm gonna be doing nested groups in the next week.
Right.
Print fields, if else. So, also, so, yeah. And then, I'm not looking forward to functions and chapter.
Yeah, that is.
Function prototypes, function headers, function calls, I guess.
Yeah, that one gets it. But once they get it, usually very good. A lot of them love to use that. I just want this note return, I can't remember which one. Void.
Oh, yeah.
I was making, I see that you're only allowed 1 void, everything else has to come back. Because if you saw it, they use 2 functions, right, they can't all be voids.
And then I was in, we're talking about the while statement today. And somebody, and I had to write a program, and somebody, one of the students says, can you put an if statement inside of a while? And I said, oh, yeah, but you gotta watch out.
See, but we know what happened with me is I'd start on the notes. There were days, and that was okay. There were days I never forgot the notes. Because somebody would say, hey, can you do this? Or on this one. And then we didn't conference.
Oh, yeah.
Spent the whole day on the
Oh, yeah.
But I tried to make sure we covered it.
Well, that's what makes it fun.
Yeah. So I'd be writing a program. I was going to write a program, nothing written before.
I know.
So I always tell them, this is what I can't tell you. I can't spell. And it's gonna guarantee that when I put somebody up, it's probably not gonna work. So we're gonna learn how to troubleshoot our own programs while we're at it. And we always had a great time.
I was doing that same thing. I love it.
So I don't do that class. If you need anything, let me know.
Okay.
I have class modified. I missed that class.
If you could check on that overhead, that would be great tomorrow.
I'll take a look. I don't know if they make an HDMI to VGA converter. They have HDMI to DVI.
All right.
Wait,
Okay. I will see that out.
what time you start Thursday?
Thursday is 1:30 to 4:30.
Okay, I can, I'll be in the before 1:30 too, because that's when I start.
Okay. All right, see you. 10%, 10% is 5%.
On the 5 band?
Yeah.
Okay, so it's not out of the tolerance.
No, 50. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would be 5, so 7, 8, 9, that's 10, which is good. And the fifth band is the tolerance, which is 0.1.
This is full. Oh, okay. And here, this
The
is.
fifth band is the tolerance, which is like these guys.
Okay.
They don't, this table is messed up. But anyway, that fifth band, you use the tolerance, or excuse me, you use the tolerances here. So the fifth band is gold.
Yeah.
Fifth band of gold is 0.1 tolerance. 0.1%, so that's 0.1%, 100% is silver. Gold. I don't know. That's confusing, I'm not gonna count those silvers.
Okay.
I wanna look that up and I'll clarify that when we come next week. Okay. Okay, so there is no such thing as a silver or gold fifth band.
Yeah.
That's the problem. So the problem is here, so I wouldn't worry about it then.
All right. And then, I guess when we have, I remember you saying about, there's a blank.
20%.
It's 20%, okay.
That would be here, that's kind of buried in the text, but there is no fourth band that's plus or minus 20.
Okay.
Yeah, everybody misses that. Hey, on the fifth, on those 5 band, Nick just pointed out that on those 5 band resistors, there's color codes. Forget that 5th band, which is the tolerance. I got a couple of those wrong. Remember, like on a couple it says silver and gold. There is no silver and gold on the 5th band. Okay, so just, if you get the first 4, you're good.
The first 5 you mean?
The 5 band resistors?
Yes. Yeah, these, don't doing
Yeah,
this.
don't worry about the, that's the 4 band. Don't worry about the 5th one here. On the,
Yeah,
on the
I'm going
5
back and
band?
fixing them.
Yeah, on that 5 band resistor, don't worry about that 5th color band.
Did we keep these or did we?
I'd like you to turn them in.
Oh, I just didn't.
Are you done?
Yeah.
Think you're good?
I actually have one question for the last two, what is the units for resistance?
Ohms.
What'd you get on that last one?
There's probably the way it went, like, I can't.
I got 5.6 times 10 to the minus
It
3.
must be the area, right?
You're right.
I think it resolves my formula.
Redo it? I'll redo it.
It's along, it's pi r squared, right, for area?
Pi r squared,
Okay, yeah. I think it's somewhere around 0.006.
me for the area.
Sorry, what there's no
5 meters. That's the diameter. That's the radius. It's squared. I get 1.96. There's 10 minus 3.
So, radius was,
The diameter is 0.05.
okay, so I was just going by that.
0.02. 0.025. Yeah. And that, and you can multiply pi without a sign, without a multiplication sign.
So subtracting in,
Oh, so you multiplied pi, so you squared pi.
oh, yeah, okay. That's it. Gotcha.
That'll work.
Okay,
Yeah. Well, I get 1.96% minus 3.
okay.
So that gives me, I'll have to resist to 2.8. So it's that divided by this one. I get 1.142 resistance. Or 142 ohms. See if we get that. Good to go?
I guess.
It's close. It's good. Whether it's 1,000. Want me to do that one? I got, 142.
Did he teach anything?
Okay, I'm gonna do a couple in every category, all right? I'm not gonna do the whole thing. So, let's just say, 1B, 6734.95. 6734.95. We want to express that in scientific notation. So, without thinking, we know that in scientific notation, that number has to be, the number portion has to be between 1 and 10. So we want to put a decimal point right there, 6.73495. We know there's a 10 to an exponent. So without thinking, that's 90% of it. Okay? Now, I don't want to change the number, I just want to express it differently. And in fact, I did change the number because I moved that decimal point 1, 2, 3 places. So this, I've changed the number at that point. So in order to get that decimal back to where it was, 1, 2, 3, I have to multiply that by 1,000 or 10 cubed. So if you multiply 6.73495 times 1,000, you end up putting that decimal back to where it was. So these two guys are equal. So the first thing you want to do in expressing scientific notation is just, without thinking, just write that down without the exponent. Write that down. And then you say to yourself, okay, how do I have to move that decimal to get it back to where it was? If I'm going to the right, I have to put a positive number there. Three places to the right, put a 3. That's 1B. 1C is just, it's a decimal less than 1. So 1C, I have 0.0 5 zeros. 2, 3, 4, 5, 5, 6. All right, okay, so without thinking, the number part has to be between 1 and 10. So if I put the decimal here, that will satisfy that number part. So I'm going to write 5.6 times 10. That's a minus sign, okay? I do that without thinking. Now, in order to get that decimal from 5.6 back to where it was, now I'm going to the left. 1, 2, 3, 4, 5, 6. I'm going to the left, so that's got to be a minus 6. Okay? Those are the conventional rules. Engineering notation, it's the same thing as scientific, except now the governing factor is the exponent. The exponent must be 3 or a multiple of 3. So the exponent must be 3 or 6 or 9 or 12 or minus 3, minus 6, minus 9, minus 12. All right? So let's look at 2A, where I have 1, 2, 3, 4, 5, 6. Three, 9, 6, 1. So in scientific notation, I would automatically put the decimal place there, 3.961. I don't want to do that for engineering. What I want to do is make sure my exponent is 3 or a multiple of 3. So if I move my decimal point this direction, I go 1, 2, 3, 4, 5, 6. That will work. I could stop there, but I'm going to go 7, 8, 9, and I'm going to say that in engineering that notation, that's 396.1 times 10. I have to move that decimal. I have to write an exponent that'll move that decimal back this way to the left, so it's 10 to the minus 9th. Okay? I could have written 0.3961 times 10 to the minus 6. That's perfectly valid. Why engineering notation? Because we're lazy people. Engineers are lazy. And I don't even like to write that or that. Instead, if I were dealing in amperes, I would substitute that 10 to the minus 9th, and I would say 396.1 nanoamperes. Nano is 10 to the minus 9th. This would be 0.3961 microamperes. Micro is 10 to the minus 6th, okay? So once you keep your exponents 3 or multiple 3, then you can start substituting your prefixes. Kilo, mega, nano, pico. milli, etc. Let's do 2C. Wow. 2916347.8.67. That's a crazy number. So I'm going to go, I want my exponent to be a 3 or multiple, so I've got 1, 2, 3, 4, 5, 6. I'm going to stop there. It's 29.16347.867. I would never write that many decimals times 10 to the 6th, because I have to go to the right, 1, 2, 3, 4, 5, 6, to get my decimal, to get my number back to where it was. So that's engineering notation, okay? On a test, if you write 2 decimals, you're good. 2 decimal places, that's it. Express the, in 3A, express the following in conventional decimal notation. You start out with 45.9 times 10 cubed. Well, I know that 10 cubed is going to be moving that decimal to the right. So I always start out by putting in some zeros. Here's where I started. So I go 1, 2, 3 to the right. Here's my new decimal. Here's my new, my conventional notation. So it's 45,900.0. Conventional notation. Resistor values, I don't have a table, so I'm just, anybody have any questions on the resistor values? The first band that is the first digit, the second band is the second digit that's on a 4-band resistor. The third band is the multiplier. It's if the third band is, let's say, orange, which is 3, and the first 2 bands, let's say, were 59, that third band you would go 10 to the cube, right? 10 to the 3. So that third band is that number right there. And then the fourth band is the tolerance. So if it's gold, it's plus or minus 5%. If it's silver, it's plus or minus 10%. And if there is no fourth band, it's plus or minus 20%. If you're cheap, you get these resistors, 20%. Good luck designing a circuit. Okay, resistivity. Any questions on any of that? The more you do, the better. Pretty soon, you'll get to the point where you won't even think about it. But you gotta practice, and you gotta keep at it, because so that it becomes second nature to you. Okay, resistivity. Let's do the second one, because that has a diameter. It doesn't have an area per se. So here's the formula. The resistance is equal to the resistivity, Greek letter rho, times the length of the wire times the cross-sectional area of the wire. And I'm saying that for aluminum, the resistivity is 2.8 times 10 to the minus 8th, and the dimensions are ohm meters. The length of that transmission line is 10 kilometers. And a kilometer is 1,000 meters, so it's 10 times 10 cubed meters. And the I don't have a cross-sectional area, I have a diameter. So the area is pi r squared. The diameter is 0.05 meters. So the radius is 0.025 meters. And then when you square that, you get R squared is 6.25 times 10 to the minus 4th meters squared. Multiply that by pi. And you get, oops. One 1.96 times 10 to the minus 3 meters squared. So that's the area that we want to put in here. And I'm going to write meters times meters. Meters squared is meters times meters. The reason I'm going to do that is because now I'm going to cancel my dimensions the same way I would numbers. So that meters cancels that guy, that meters cancels that guy. The only dimension I have left is that ohm right there. So when I multiply that out, I get 0.142 ohms. Okay? So it's not really that bad. You just have to be mindful of the information that you're given and know where what you have to do with that information to get the answer. We're looking for area, but we weren't given area, we were given diameter. So we have to convert it to area. Okay, any questions? I'm going to send out a study guide this week, and make sure you check your emails, check the Blackboard course information, and that should prove pretty helpful for you. And I know everybody's tired, so we can go home.